there's your claim. Oops, this is one we did yesterday, right? Okay, let's go to number 10. Sorry. Okay, number 10. The U.S. Department, and it is on the next page, 356. The U.S. Department of Agriculture reports that the mean cost, population mean cost of raising a child from birth to age 2 in a rural area is $94.05. You believe this value is incorrect. So therefore, you get a sample of 900 children, and you find that here's your sample information with the standard deviation of 1540. You'll appreciate your parents after this. And this was like 15 years ago, so you can imagine the price now. And at a level of significance of 0.05. Is there enough evidence to conclude that the mean cost is different from? How do I say different from? Not equal. So I've got an equal to, and I've got a not equal to. Which one is my HO? Which way does my tail go? Tail. Okay, now, they drew out your two tails for you, but we're just going to work that out, because when we do the reject region, I want you to remember we're going to split those in half. Yes? Two tails because of the not equal. The left end points left, the right end points right, not equal to tails. Now, which one is the claim? The HO? Well, here's what they want you to examine. Can you conclude that? In other words, they would say, can you support the claim that? Can you reject the claim that? Got to play with the words in this. It doesn't always fit into what we think it's fitting into. Normally they say this, is there enough evidence to reject the claim, to support the claim? So let's kind of put that right in here. Let's put this in here. That the mean cost is different from. So what would be your claim? HA. This is your claim.
Why would HA be?
Because you're testing your claim against your claim, right? You want to say, should I reject the claim? Should I support the claim? So when we get here, take this statement out of here a second and replace it with the word claim. Is there enough evidence to reject the claim? Is there enough evidence to support the claim? The claim that the mean is different from this.
Because I just thought the first sentence.
I would have thought so too, until they hit us with this last sentence. That's just a report. That's just a report. That is about your population. Now you're coming through and claiming something different. That claim it can fluctuate. It can be to support something, it could be to reject something, it could be like when you support something, you put additional information in there to prove that it's good. If you want to reject something, you put additional information to reject what is there. But your claim could be the part that you are stating. So I want this to be different from, my claim is, this is different from that report. So in English, it's sometimes tricky the way they word things. They don't always use the words that we're looking for. So when you get down to here, is it usually that last statement, usually doesn't it say, is there enough evidence to support or reject the claim that? So if we can take that and stick this in here for now, and put the word claim in here, is there enough evidence to reject or support the claim that it is the mean is different from 9405? So now we hit the fact that this is my claim.
So like what are you using? Are you using reject or support?
Well, if the not equal is my claim, and that's an HA, should I use the word support or reject? I need to support it now. I didn't know which one. I'm just saying, like when you reach this sentence, we normally say, can you support the claim that? Can you reject the claim that?
Because different from means not equal.
Not equal to. So I just wanted you to catch that this is where the claim is right here. This is your claim. And it's tricky. Like, why would they do that? Why would this person do this sample and state that claim himself? Because he wants to say, I think it's different from, this is my claim. Now I'm going to show my information to prove that I am right. I'm going to support this with my information. Usually when it's a support, it's trickier. A reject is usually more obvious, but a support is a little different because you want to show that something works that way. So you want to show that it is different from his statement. Even though this is his statement, it doesn't have to be his claim. Let me see if they explain this a little bit better. No, they don't. So you got to kind of play with your words a little bit. So now, we have a two-tailed test. So two-tailed tells us, here's a reject, here's a reject. Label, reject H0. Make sure you label these sections. Fail to reject. Remember, the part that we reject is very small. We only want to reject it if the area is less than or equal to the level of significance, the one that we'll allow. So our goal now is to find this cutoff point. Whatever it is on the left, it's the same as on the right. We have a two-tailed test. Our level of significance is 0.05. That means both of these tails have to add up to 0.05. So we have to do inverse norm for 0.05 divided by 2. I want to know what that z-score is for this guy. So plug it in your calc, 0.05, do an inverse norm. Do this so you get used to doing this. So when you have to do one on your own, you say, I don't know what to do next. It lets you put that right in. You don't need a parentheses. I just drew parentheses around it. So what's your z-score for this? Okay, so we know the negative exists on this side and the positive exists on this side. These are called your critical values. This is where we cut off. This is our cutoff point. So now when we do your test statistic is your z-test. You can use your calculator, you can use the formula. This is from your sample. So we use the z-score test. Now, what they're doing here too is they're using a very large sample. This underneath here is going to be extremely large. So you take your sample mean, you subtract your population mean, you divide it by your standard deviation, divided by the square root of 900. The square root of 900 is 30. That's a large number. Normally we work with like a 2 or 7 or 10 by the time we take the square root. So you plug this into your calculator. -2.24. This is your z-score test statistic. It came from your sample. Now we need to see where it fits into this graph. So this is your number line to 0. Where would the number, look at this number line, -2.24 fit? And the reject, it would fit right in here, right? It's a number line. So it falls in the reject H0. I think this kind of makes your decision a little easier. You don't have to test against the p-val. And I think sometimes looking at it, having a visual, is a lot easier to understand something that's so abstract to you right now. It's population, sample, what does she mean by p-val, area under the curve, what is that supposed to mean to me? So I think when you look at a visual and you can actually see, oh, this is where it fell, reject H0, it kind of makes a little bit more sense. It may be a little bit longer to do this, but I think it makes a little sense. So we reject H0. This is your decision. Now, To interpret this, we go back to the claim. The claim is the HA. We're here. We reject HO. Therefore, we don't like HO, we like our claim. So we say, there is enough evidence to support the claim that the mean cost of raising a child is different from 9405. I need that last statement. That's the statement you present at a level of significance of 0.05. Good? Okay, you guys try it yourself. 10. The one right underneath this. I want everything. Alright, so let's make a new chart over here. This is at a level of significance of 0.01. So your room for error is much smaller. I want these new values. These new critical values. Yeah?
Negative 2.57 and positive 2.5.
Okay, or 2.58, right? How'd you get it? Okay, Anthony did inverse norm 0.01 divided by 2. This 0.01 has to be shared in two places. So he got negative 2.575 or negative 2.58, that's fine. And remember, it's symmetric, so this is the negative side. This is the positive side. Now you come down and you take your same test statistic, nothing else changed. Your test statistic was negative 2.24. Now, giving you more confidence, less error, you now fall here. And you're failed to reject H0. Less error, more confidence. Okay? So the two-tailed test again, make sure you remember to split it in half. A right-tailed test, make sure if you're looking up your area, if you look it up without subtracting it from 1, it's a negative, make it positive when you put it on the right-hand side. Or look it up 1 minus that, and you'll get the positive. Make sure it fits your chart when you set these up. Good? Which one do you guys like better, the p-val or the reject region? The reject region, I think, it brings it to you a little closer.
So what would be the statement for this one?
So the statement for this is, we still have the same thing. Claim is HA, so you're here, and you failed to reject the HO. So if you didn't reject something, you had to keep it. So therefore, you can't support the other one. So you follow it across and you say, at this level of significance, 0.01, there is not enough evidence to support the claim that the mean cost is different from 9405. What, in your head, remember what that other sheet said? You say, it's true, it's false, it's probably not good, not right. You say that in your head, but then you use the statements that you're supposed to use. Okay, I'm going to give you a little assignment. Everybody's good with this? Alright. Alright, page 358. And I want you to use reject regions. I want to see sketches and reject regions on these. The first couple just have you look at the charts and see where they're rejected, see where they're not rejected. So it kind of helps you get started.